some of the latest updates from container security, which were announced at Microsoft Ignite. So last month, or maybe the month before, we did a previous webinar as well on updates around container security in Microsoft Defender for Cloud. So if you're interested in hearing about additional updates that maybe weren't discussed in this webinar, I would recommend viewing the previous session as well. But today here, we're going to close the gap and discuss some of the latest additional updates. So for this discussion, we'll start off talking or reviewing Defender for Cloud and the container security capabilities that we have. And then we're going to break it down into 3 different areas. So looking at the updates that relate to DevSecOps, then we'll take a look at cloud native posture and runtime threat protection. So if you're not familiar with Microsoft Defender for Cloud, essentially it provides different capabilities to secure your cloud environment from code to runtime. And when we think about container security and Microsoft Defender for Cloud, there's different areas that we cover. One being DevSecOps, which is looking at enabling secure deployment. So protecting the containerized environment in all its development stages, and checking for any vulnerabilities and misconfigurations as early as possible in the life cycle. Then we provide posture capabilities as well to help you continuously monitor and reduce risk. So this is looking at getting visibility into the entire Kubernetes estate and offering security best practices with compliance, as well as securing images while they're in runtime or in production, which relates to this last part here, the runtime protection. So being able to generate near real-time detections, which includes agentless detections and agent-based detections as well. And we also have a lot of cool capabilities that we released, which relate to the investigation and response part that we'll cover later on in this webinar. So essentially, as you can see, one thing to call out here is that Defender for Cloud covers not only Azure Kubernetes service, but we also protect Kubernetes in other cloud environments, such as AWS, which is seen here, and GCP. And then when you're looking at the DevSecOps stage, we've extended our support there. And some notable things that you'll see is the support for JFrog, and we actually announced support for Docker Hub registries earlier this year as well. So taking a closer look at the announcements around DevSecOps. So one thing I want to discuss first is the container software development lifecycle. So the journey of a container image from code to runtime involves several important steps. And the first is the application code. So the application code is developed and then built and tested, and it's packaged into a container image. That image can be stored in a container registry where it can be pulled when it's needed for deployment. And then those images are deployed to a cloud environment where it can be run as a container. And throughout this journey, the continuous monitoring and updates are crucial to ensuring that the container remains secure and up to date. And one thing to keep in mind here is that all these levels need to be secure, because it only takes an attacker to find one weak point within this development lifecycle to attack the system. So with that in mind, we've released a couple of updates here which relate to the secure development, the software development lifecycle. So one of the things I first want to look at is the support for external registries when we think about the vulnerability assessment scanning. So as I mentioned before, previously we announced support for Docker Hub registries, and we're extending that we're extending our coverage for external registries to also include JFrog Artifactory, and this is specifically for SaaS JFrog registries. So the same way that you're able to scan for vulnerabilities in ACR, ECR, GCR, and Docker Hub, we're extending that to JFrog as well. Let's take a close look at what this would look like in the Azure portal. So here I've gone ahead to the environment settings page, and we can see the different environments that we have onboarded, and JFrog being one of them. So I can add an environment here, and then when I select JFrog, so I can create a name for the connector like I do with onboarding the other environments. And this connector is really just signifying the relationship between Defender for Cloud and JFrog. I'm going to select the location, subscription group, and subscription and resource group to store that connector. And notice here that I can select scan intervals. So this is saying every 4, 6, 12, or 24 hours, I can have my Artifactory registry scanned. And then I'm also going to add a server ID, which is essentially, it will explain it to you here. It's the name of the JFrog Artifactory account URL. So once I configure these details, then I can select a plan that I want to be used on the Artifactory connector. So I can choose the foundational CSPM, which is essentially just going to show inventory of this Artifactory registry. I can also enable Defender CSPM or Defender for containers, which will both give me the vulnerability scanning, but with I can get the additional capabilities that come with either plan as well. And as you can see, it's currently free during preview. And then, so once I configure, or once I select the plans that I want to enable, I can configure access. So it's essentially going to create a script, which I will run using the JFrog command line. And then taking a look there, it's actually going to create resources within my JFrog Artifactory. So here you can see it created this MDC group, which is essentially, so this is using OIDC authentication. So it's creating this group here, which has read permissions to my repository. And you can see this includes any local remote or any distribution here. We can see the MDC read permissions. So this is essentially all it's doing in my Artifactory registry. It's getting access to view the images that I have stored there and scan those images for vulnerabilities. And then if I go back here to Defender for Cloud, so once that registry is scanned or that image is scanned, I can see those scanned results in Defender for Cloud in the form of a recommendation. So here I've gone to recommendations and I filtered for the JFrog connector. And as you can see, it's going to report for each image that was scanned. And if we just take a closer look at one of these recommendations here, we can see the format here is really the same as with any other image that's been scanned for vulnerabilities. So it's going to give me that background, if this image is included in any attack paths, the scope here, which is the connector I've created, but also the repository, and then an overview of the findings. And I can see the image details as well, such as the image URI, the digest tags, etc. And then in the findings section, I can actually see the findings that were generated for this image. So again, the experience here is very consistent to what we have for other images. When I click on the CVE, it's going to give me that background description in terms of what was detected here. So I get the summary, the impact, remediation. And as you can see, I can see other details here, such as the package type, vendor, package name, I can see the current installed version of this software, as well as the fixed version, and I can still see the exploitability information as well. So if any exploit steps were published for the CVE, if those exploit steps have been verified, or if they exist in an exploit kit. And then in addition to that, you would also find um, that image in the Cloud Security Explorer. So the same way that you're able to discover images in Azure, AWS, GCP, and previously for Docker Hub, you can do that for Artifactory as well. So we can say container images, that, and then we see the metadata here, the cloud provider, and then we can filter for JFrog. We can also see additional insights, such as if there's any installed software. And that will show in the results here. And we see the image URL, and taking a closer look here, the tags, and we get the insight here that it has the installed software. All right, so taking another look at the other things that we released here in terms of the software development lifecycle. So one thing that we know about security and the remediation when it comes to container-related assessments is that security teams will conduct regular assessments to identify any potential threats. But in addition to identifying these threats, they also have to collaborate with different stakeholders. And when we think about container-related threats, this could also include the cluster administrator. And these cluster administrators are really vital in ensuring the application integrity. So they have to, they often help apply patches to the containers and help with any posture misconfigurations. They also have a stake in the security of the posture, the security of the cluster as well, because they need to make sure that these clusters are up and running and secure, and the applications are available that were deployed on these clusters. So in cases where there's active exploitation, it's really necessary that there's quick coordination between the security teams and the cluster administrators, because these cluster admins are supplying essential information and help that may be needed for the remediation process. So with this in mind, we've updated the Defender for Cloud UI for the AKS cluster. So here we're introducing the Azure Kubernetes Service Security Dashboard. And essentially with this dashboard, you're getting an overview of the vulnerabilities on your running containers, but also on the host as well, which we'll take a closer look at later in this session. You also get a look at the recommendations, the posture recommendations that need to be remediated on the cluster. And you can assign these recommendations to an owner. You can assign both the vulnerabilities and the recommendations. And you can also onboard your cluster as well to Defender for Containers. So let's take a look at what this looks like in the portal. So, so if we go to what I've already done here is I selected a Kubernetes cluster, and then I went to the Defender for Cloud section for that cluster. And we can see this updated UI. And what we're doing here is help bridging the gap between the cluster admins or the platform engineering teams and the security teams. So for this single cluster, I get an overview of all the security findings. I can also see that Defender for Cloud or Defender for Containers is on, and it's telling me that it's enabled on the subscription. And you can see like which toggles have been turned on as well. So this includes the Kubernetes API access, the registry access, and Azure policy. But in addition to that, I see the vulnerabilities that have been detected for this cluster. So I can see these vulnerable containers, and if I were to click on a single container, it's going to show me all the vulnerabilities that were detected here. And I get a quick summary of the fixed version of the software and then the installed version as well, and also the CVE that was detected. And you can see additional information such as the image name for this container. You can also see the controller name and the pod name. And we see that this is actually part of a replica set. Um, and in addition to that, I also see the host level vulnerabilities. So we'll take a closer look at the host scanning soon. But you can see that information is made immediately for um, it's made immediately available in the security dashboard. So if I click on the node here, I see the affected agent pool. So it tells me the name of this VMSS and the CVE that was detected on this VMSS as well. And then in addition to that, I can also use different filters. So if I wanted to filter to view by a specific namespace or image, I can do that. Um, and in addition to seeing the vulnerabilities, I can see misconfigurations as well. So these are posture recommendations um, that need to be remediated just for this particular cluster. So by clicking on the recommendation, it gives me a description of what was being checked for in this recommendation, as well as the remediation steps. And one thing that you'll see in both views is that I can actually assign an owner. So I can directly assign remediation of either this recommendation or one of the vulnerable host or containers that was detected. So what I would do here is select the recommendation, and then here I can set the owner by typing user account name or a group name actually, and set a remediation time frame. So I can say that for this one, maybe Christmas is not a good date, but I can set any other date here to be remediated. I can also apply a grace period, which would not affect the secure score, and send email notifications as well. So I can send a weekly report to the owner, and I can also send a report to the owner's direct manager. So taking a look at um, an assignment that's already been created here, we can see this was assigned to Barry's, which is past remediation here, and it's set to send these weekly notifications. All right. So going back to our discussion, so we looked at some capabilities that relate more to DevSecOps. Now we can take a closer look at the cloud native posture announcements. So first off, we announced general availability of the manual criticality classifications for Kubernetes assets. So this would allow you to create a critical asset rule for not only different Kubernetes assets like the cluster or the pod, but also based on different labels or namespaces that can exist on the cluster. And these tags will be reflected in different CSPM capabilities, such as the recommendations, inventory, and attack paths. In addition to that, we also released automatic classification of different container assets or automatic classification rules. So in addition to being able to manually create a classification rule, we also have predefined rules as well. And this introduces 4 different predefined rules. So the first one would be for a locked Azure Kubernetes service cluster. So this is assigning a rating to a cluster that's locked. The next one here, or the next 2, are focused on multiple nodes. So if the AKS cluster has multiple nodes, or the Azure Arc enabled cluster has multiple nodes. And then finally, the last one is for premium tier Azure Kubernetes Service Cluster. So for all of these asset criticality rules, what you'll see in Defender for Cloud is that when you go to the environment settings, there's this resource criticality blade, which will take you to the security.microsoft.com portal. And in there, you can see this critical asset management. And first off, you'll see that we have these predefined rules. And going all the way back up here, so we have these predefined classifications. And you'll see there's several different rules, but this is where you would find the rules which are related, which are predefined, as I mentioned before. And so, for example, we see the one for locked Azure Kubernetes Service Cluster. So just taking a look here, so it's giving it a low tier criticality rating, but you can see the description here in terms of what is being um, detected for the critical asset rule. And you can actually see which assets were detected when they were found. And you can actually turn off this this rule as well. So you can't delete it, but you can turn it off. And then in addition to that, you can see the other rules that I mentioned. So the one with AKS cluster with multiple nodes, Arc Kubernetes cluster with multiple nodes, and then the premium tier cluster as well. And the same as we saw before, it shows you the criticality level for this rule, the description, and you also have the option to turn these off. In addition to that, you can actually create your own custom rule as well. So here you would assign the rule a name, or you would assign the rule a name and description, and you see the option in the query builder to choose cloud resources. And what you can do here is select a filter, and you can select different resource types, which would include the cluster itself, or you can select different labels or namespaces that may exist on the cluster. So looking at labels, for example, we can create a rule that says labels equals, and then it will show us all the labels that have been detected on our Kubernetes service clusters. So once you create these rules, you can actually go back in Defender for Cloud, and you can see that when there is a critical asset detected, we have these tags here that show that the asset is critical. In addition to that, you can find this information integrated into other areas, such as attack paths. So here we see internet exposed container with high severity vulnerabilities allows lateral movement to critical Kubernetes cluster. And then here we see the critical cluster, which is marked by this crown rating. So in addition to the critical asset rules, we've also provided some updates for the Kubernetes CIS benchmark. So previously we did support the 1.4 version of the Kubernetes benchmark across all 3 cloud environments, and here we've updated to 1.5, which includes additional recommendations. So what you'll see in the portal, so what you'll actually see in the portal here is, if we go back, and go to, if we go to regulatory compliance, we can see an example of where it has already been applied. So you can enable this again for all three cloud providers, um, Azure, AWS, and GCP. And once you do that, you will see additional recommendations for the Kubernetes CIS. And just my luck, everyone's trying to demo at the same time as me. All right, so yep, we can see 1.4, but we also see 1.5, which has been applied. And if we expand the compliance controls here, you can see that we have way more recommendations than 1.4, but you can see all the applicable recommendations that have been added as part of this benchmark. Now, another thing that I want to discuss as part of cloud native posture is the Kubernetes host. So previously we saw the host scanning and the security dashboard, but let's take the closer look into that. So we know that cloud providers offer managed Kubernetes services. We're familiar with AKS, GKE, and EKS, and we know that it is a shared responsibility. But previously, the AKS hosts and nodes were not something that was covered by Defender for Cloud. Um, and we know that vulnerabilities in the host could introduce risk, which are susceptible to being a source for the attack. Um, and we know that it's possible for the host to not be in compliant. So what we're doing here is really reflecting vulnerabilities that were detected in the Kubernetes nodes and bringing visibility to that in the Defender for Cloud portal. So this would require you to be using either Defender CSPM, Defender for servers, or Defender for containers. And you'll see that you actually have the option to enable agentless scanning for machines as part of Defender for containers, which will give you this host level visibility for the vulnerabilities. And these vulnerabilities, as we'll see in a minute, can be remediated by updating the node pool VM image version. Um, and the customer upgrade here is part of the shared responsibility model between the Kubernetes service and the customer. So if we take a closer look at to how this agentless scanning works, so this is actually using the same agentless scanning for machines capabilities that we see with virtual machines. So in this case, we have the AKS VMSS, and what we're doing there is taking a disk snapshot of that VMSS, and we perform this scanning in an isolated environment, which is in the same region. And then from there, we're able to create this vulnerability assessment, which includes results for the scanning, and show that to you in the Defender for Cloud portal. So if we take a closer look here, this would be an example of one of the recommendation you would see for the host level vulnerability scanning. So here we see the remediation steps, which is essentially telling you to upgrade the related node pool version. We see the affected resource, which could either be the user pool or the agent pool, and then the security findings that were detected. So taking a closer look at one of the user pools here, we can zoom in on these findings and see what was detected on the VMSS. So we get this description, impact, and then again in the remediation step, it's telling us that we can enable the automatic upgrade for the user pool, or we can also upgrade the version of the related node pool as well. And with that in mind, another thing that you'll see if we go back to the Defender for Cloud portal is that when we go back to our subscription here, so selecting a subscription, and then the Defender plans, what you'll see is that in order to use this capability, you need to turn on the agentless scanning for machines, and you will see that for not only CSPM and servers, which was available before, but you can also see that as part of containers as well. So those were the key things I wanted to share as part of the DevSecOps and posture updates. Now I'm going to hand it to Vasavi to discuss the runtime threat protection.
Yeah, thank you, Future, for valuable insights about the runtime, the secure container posture management. So I'm going to walk you through the container security related to runtime threat protection. Uh, just wanted to make sure I'm audible and my screen is visible. Okay. Uh, so going forward, what Future has shared here, in addition to what Future has showcased about the agentless scanning for machines capability. So the same capability also provides malware scanning capability on the Kubernetes host. So here comes the agentless malware scanning. So this is provided by agentless scanning for machines, which also helps detect malware on AKS nodes. So malware on AKS host can introduce security risks like lateral movement from the host to the container running in the host, or it can affect other nodes within the cluster. So agentless malware scanning uses the Microsoft Defender antivirus anti-malware engine to scan and detect malicious files, and it will throw an alert. And malware detection for AKS nodes is available only with workload plans, that is Defender for Containers plan or Defender for Servers P2 plan. Only when you enable these two plans, you will get this capability of malware scanning on the Kubernetes host. Please note that the agentless machine scanning capability is available on Defender CSPM plan as well, but that alone will not help in detecting the malware for Kubernetes hosts. You need to turn on agentless scanning on Defender for Servers P2 plan or Defender for Containers plan. So coming to the look how this looks like on the alert page. So here is the alert. We can see if the affected resource is the entire VM scale set, or here you can see if it is going to be the which VM scale set, whether it is affected resource is going to be the entire node pool with or the VM scale set, or if it is going to be the affected resource is a single instance within the VM scale set. So the scenario malware affected during runtime in Kubernetes nodes can be, say, applications running on worker nodes which downloaded the malware during runtime. And this can break out from the container and spread to the underlying node as well. So it is customers' responsibility to fix this issue. So in this scenario, say malware affects a single instance within the node pool. So the fix should be isolate or kill the particular VM instance. Or another scenario could be malware originated in the Kubernetes node base image itself, which is provided by the cloud provider itself. So in such a scenario, malware will be found on all nodes created from this image. So the fix should be to upgrade the node pool version itself. So the in case of malware alert is a false positive, say in case you find the alert has been triggered, but the malware is alert is a false positive in your environment. In such a case, you can submit it for analysis and our analyst can analyze the file. And they going further, this particular file will not be considered as a malicious file or a malware file, and it will Defender for Cloud will not trigger any more alerts saying it is a malware. Okay, going to the next feature that we have recently released is about Kubernetes process alerts powered by Microsoft Defender endpoint. So this is a enhanced alert capability for threats to Kubernetes control plane and as well the data plane. Or when I say data plane, it can be the workload runtime. And these are provided by Defender for Containers plan. So when threats are detected, security alerts are directed into Defender for Cloud and as well the Defender XDR portal where they can be investigated and remediated. So how these alerts are being triggered, like Defender for Cloud will collect Kubernetes audit logs, monitors the activities of the Kubernetes API server, and it will provide the control plane threat protection. Similarly, for the data plane threats, the Defender for Containers uses Defender sensor, which sits on each and every node within your cluster to monitor the Kubernetes workload runtime activity, and it can detect the suspicious operations, including workload process creation events. So all the critical events are captured that indicate any potential security threat or any suspicious operations, be it by service accounts or exposure of services. Those incidents will be captured by the sensor and that will trigger an alert. So behind the scenes, Defender for Containers uses Microsoft Defender for Endpoint and Microsoft Defender Threat Intelligence. That's how it is going to detect these alerts. And one interesting addition here is we now have an alert simulation tool. So if customers want to test Defender for Containers in a POC environment, they can download the simulation tool and test the alerts. So as I was saying, the prerequisites for this would be you can detect alerts or threat scenarios within Azure AKS environment, AWS EKS or Google Cloud GKE clusters as well. And the prerequisite is Defender for Containers should be enabled and Defender sensor must be enabled. And to deploy this, you need the security admin privileges within your subscription. So let me take you to how this simulation works within my environment. So here is one cluster that I have. So here is the documentation where this talks about how to download the simulation tool, how to install the simulation tool and run it on your cluster. So you can actually run this on your cluster. So let me take you to the Cloud Shell. So here you see I just initiated this simulation tool within my cluster. And so what it does is it gives various use cases that you can trigger for your simulation. So when I say Python simulation.py, so the Defender for Cloud attack simulation is launched. And here you can see that different scenarios like reconnaissance, lateral movement, secrets gathering, crypto mining, web shell, and or you can also trigger all of these scenarios at once. So I selected the scenario to be 6 and it goes ahead, the simulation goes ahead and creates the resources. So what it does within the cluster, within my cluster is it creates two pods or two pods here. Let me show that. So within my cluster, when I launch this attack or when I launch this simulation tool, so the simulator creates two pods. One is MDC simulation attacker which is launching attacks towards the MDC simulation victim pod here. You can see. So here the two different pods are created within my cluster here, and the attacker pod is going to launch the scenario based attacks to the victim pod. That's what we are selecting here, right? So here you can see because I selected all the scenarios here, it is going to launch all the kind of scenarios, web shell, or it is trying to do the reconnaissance, and it is also going to do the scanning or port scanning and all these things. And also it is going to launch all these scenarios. So if I want to launch another attack, say it will ask me to trigger a particular scenario. Say I want to launch only a particular scenario, and it will go ahead and create the simulation here, creates the relevant resources and launch the attack. So once this is done, we can also see, let me wait for the alerts to be triggered. Yeah. So the simulation is completed. So it will ask you further to run another scenario, or you want to conclude this attack simulation. So once this is done, within no time, you can also see the attack alerts, because we have just launched the attack. So you can also see the alerts that have been triggered here just now. So here you see there is suspicious Kubernetes service account operation detected, digital currency mining related behavior detected, binary drift detected, possible crypto mining download has been detected on this cluster, and command within the container accessed. So all these alerts have been triggered. So here we can choose the simulation attack, the scenario, whatever you want to simulate. And in the XDR portal, you can also see all these simulation alerts have been triggered and also coming into the considered as the incident, and it is also seen here. So here we can see the same cluster, Alpine K8 MDC is the cluster that I have just triggered my alerts, and you can see all these alerts are popping up here. So this is the scenario that we can trigger using the simulation tool, and you can also try it within your POC environment. The next feature that I wanted to talk about is the cloud process events, which are now integrated into Microsoft XDR Advanced Hunting Portal. So the new cloud process events table, which contains the process information that is observed in multi-cloud hosted environments such as Azure Kubernetes Service, Elastic Kubernetes Service in AWS, and GCP Google Kubernetes engine clusters as well. So this is useful for hunting scenarios to discover threats which can be observed through process details that like say malicious processes running within the cluster, or there are any command line signatures that you want to detect using these cloud process events. So the security alerts include cloud process events data and also the process tree details for a process, and we can investigate it in advanced hunting portal. So again, because this is a runtime threat detection, we also need Defender for Containers plan to be enabled and Defender for Containers sensor to be deployed. And we can see this cloud process events within in the Defender XDR portal. Let me take you to the XDR portal here. And let me take you to the advanced hunting. So under in the XDR portal, under investigation and response and advanced hunting, you can look at under the cloud infrastructure. We can see the cloud audit events and cloud process events. So the cloud process events is the table that is recently added, which talks about the process events, that is the Kubernetes process events that are happening within the Kubernetes data plane can be observed here. So these cloud process events belonging to your Azure or AWS resources, all the kube audit events will be ingested here. And you can see the container related image name, Kubernetes namespace, Kubernetes pod, and Kubernetes resources, and all of these details here. So what we can do with this cloud process events, so there are multiple things that you can detect using this cloud process events. So we can view the table cloud process events and hunt for discovery, hunt and discover any threats which can be observed through the process details. So one common attack scenario is using a port scanning tool via something like Nmap tool that is being used by the attackers within the cluster. So say suppose we want to identify such scanning tools being run or executed in our cluster. I can run the query in the cloud process events. So here I have run this query saying cloud process events table, and whenever the process command line has nmap, or whenever the process command line has any network scanning tools that are being run within my cluster. So here you can see there is one such activity happening within my cluster. So here the process name, which is nmap, that is run by a particular account. So you can go ahead and investigate further, like who triggered this process, what is the intention of this running this network map nmap tool within this cluster, whether it is a internal administrators running these commands within the cluster, or is it an attacker that is running this tool within the cluster. So this can be helpful. The other kind of query that we can also make here is say any service tokens are being escaped. So when we say service token, a account token in a pod is to provide that identity. So processes use these service account tokens as an authentication mechanism to communicate with the APIs. So if service account tokens can be a way for an attacker to escape out of the container or even compromise the entire cluster when it has risky permissions. So here we can run the query, say asking if there is any service account token read activity that is happening within my cluster. So this is the query that I have run to query this process, and here we see there are two records that were found here. So we can see this was run at certain time, and which process has initiated this and which account has initiated this. We can go through the entire details and take any relevant action to fix it. Okay. Going back to the next feature is about the cloud detection and response. So what is CDR, cloud detection and response? Or what is the need for CDR? Say when we already have so many tools like EDR, XDR, and all that, right? So I will take a pause here so to explain what exactly is CDR. So CDR is specifically designed for cloud environments that focuses on proactive threat hunting. And this is real time. This focuses on real time threat detection, quick and automated incident response. So if you look at the traditional tools, they lack understanding about the cloud's rapid scalability or ephemeral resources or dynamic environments, and also the global distribution of services and data. So MDC is now also considered as a cloud detection and response tool. So because MDC has visibility into Kubernetes workloads, roles assigned to users or service accounts inside the Kubernetes workloads like such. And also with MDC integration to Defender XDR, this brings rich context to investigations that span cloud resources, devices, and identities as well. So the CDR can prioritize alerts based on resource criticality, based on businesses and workload priorities, reducing the impact of security incidents on business critical resources that Future has just walked through about how to identify your business critical resources by tagging them as critical resource within your environment, right? So Defender for Cloud has now evolved into this cloud detection and response tool as well. So let me walk you through some of these cloud native response actions that we have added in the recent times. So as I said, CDR key feature is to quickly detect and respond to the threat and minimize the blast radius. So starting with container workloads, we introduced cloud native response actions for pods, which is in public preview as of now. And this currently we offer two such actions. One is network isolation, which uses network policies to restrict traffic containing the attack and preventing further lateral movement of the attacker. Or it can be a pod termination, which removes the compromised pod from the environment, eliminating the threat entirely. So SOC teams can quickly and effectively contain and mitigate threats in container workloads, isolate a pod exhibiting any malicious communication patterns. This can include scenarios where a pod is making excessive outbound connections to known malicious IP addresses or engaging in a suspicious data transfer. So let me take you to the portal. Let me showcase that in the XDR portal itself. So here comes, there are certain prerequisites for this to happen. So here comes one of the prerequisites here is you need to perform these network isolation activities. You will need permissions. So in the XDR portal, if you look at the permissions under the XDR roles, there are two roles that are required for this: MDC manage response and Defender for Cloud manage alerts role. So these are the two permissions that you will be requiring to manage these network isolation and pod termination activities. So let me take you to the one of the pod here. So let me pick up the same cluster. And if you look at the pod, say, so here you can see isolate pod and terminate pod. There are two such actions. So whenever you see a pod is suspicious, say you want to isolate the pod and investigate it. So when we say isolate, you can also mention the reason why you want to go ahead and isolate this particular pod, because you want to, the SOC analyst want to go ahead and investigate it. And if it is something suspicious, they can investigate. And if it is not being any malicious activity that is being performed, you can the SOC analyst actually can go ahead and also join it back to the cluster. Or if the SOC analyst finds that the pod is already attacked or it is performing some malicious activity, that can be terminated by the SOC analyst right from the XDR portal itself. So they can go ahead and say terminate. So all these actions also will be logged under the action center. So here you can see we just created this actions like what has happened in the action center. Under the history also you can see those actions that we have performed, like isolate pod and terminate pod actions have been registered in the history as well. Okay. Let me go back. So a few more capabilities that we have introduced in the recent times. The Go Hunt experience in the XDR portal. So Go Hunt action helps get the full scope of a container attack, and we can view all process events and activities related to container related incidents. So here, as I shared, we do have the cloud event tables. So again, let me take you to the XDR portal. And here we can see under the advanced hunting, we do have cloud process events and cloud audit events tables. So what this cloud events table does is it contains cloud audit events from cloud platforms containing kube audit logs, which holds information about Kubernetes related events, and also from multiple sources like the multi-cloud audit events. Also, you can see the cloud process events table, which contains information about process events in multi-cloud hosted environments such as AKS, Amazon EKS, and Google Cloud Engine as well. So we can run these queries using this Go Hunt capability. Let me take you back here to Go Hunt. Yeah. So here we can see we can if you click on this, it will take you to the Go Hunt. You can click on the activities that has been performed here within this cluster, and you can investigate with all these logs that are seen, all the activities that have been performed within this particular cluster. Okay. And the last feature that I wanted to showcase is about the guided response for containers in XDR. So this is about the security copilot in XDR providing guided responses for container response actions. So this feature empowers our customers to effectively respond to any container related threats, improving their overall security posture. So even users with limited container security experience can benefit from this guided response experience. So what this looks like within the XDR portal, again, let me take you to the XDR portal. So here, if you look at the Copilot tab here within the cluster. So within the XDR portal, here you can see there are guided response. So once a threat is found within the cluster, what the SOC analyst or the administrator can do here. So it gives you the complete incident summary about what exactly is the threat, what is happening within this incident, and it will then give you the guided response. So what should be the next steps that the SOC analysts need to take to remediate this? So here you can see there is a triage process, and it also gives the classification opportunity to the SOC analyst. So the SOC analyst can go ahead and classify the incident, whether it is a multi-staged attack or it is a malware attack or whatever is the kind of attack that, or if it is a false positive and they want to just flag this as not malicious. So that can be triaged by the SOC analyst. And further, say if it is identified as a attack and the SOC analyst wants to go ahead and uh, do further investigation. So it can be because this incident has been they can go ahead and investigate. So in that process, they can take the pod into isolation. So the probable actions here could be isolate the pod, and further after the investigation, if it is found to be malicious, that can be the next step is to be terminating the pod. So it will give you the SOC analyst the step-by-step process, like what when an incident happened, what should be the process that the analyst needs to perform within their environment. So this is about all the recent features that we have announced at the Ignite. And I think we can open up for any questions here.
Great. Thanks so much. The team's been great with answering questions. We are over time, so I don't think we have time for Q&A, but all the questions, or most of the questions, seem to have been answered in the chat. So with that, I'd like to thank you, Future and Vasavi, for being our guests and for sharing the great information with our community. Also, thank you to the Q&A team who helped us with answering the questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/security community. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech Community discussion space at aka.ms/mdc community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.